Okay, this is a Hacker Gondolier Gp42 record player from, I suppose, the late 60s, early 70s. Quite a well-known record player because it had a very good sound quality, high quality amplifier, garage turntable. This one I picked up locally for me on a Facebook website. A woman was selling it, it used to be her grandmother's, and wanted to get rid of it, it'd been in the loft. And I saw it on there, and it was sort of like, she said sort of open to offers, so I made her an offer and she accepted it straight away, which is good. Probably meant that I offered too much. So this is the side view of it here. We've got the volume controls at the side, tone for bass and treble at the side, and you see the finials falling off on the side here, but we've got one of those. She said she found it and put it in the bag. There it is here. But not only that, it comes with all the original paperwork. It comes with the original information on the garage turntable. This would have been obviously on top of the turntable when it came. We've got the a card in telling you basically its specifications and how wonderful it is. We've got a Hacker brochure here of all their other radios, which is great. That's really going to be interesting to have a look through that. And we've got one of the old EMI sort of dust cloths for cleaning the records off, which weren't that great in the day, but that's obviously the original one. Warranty card, the ferrule that sits in the centre of the turntable for, I think that's what that is anyway, for the auto changer or just a normal spindle. I'm not sure, I need to check that. And then we've got the instruction manuals on how to use it, so full instruction manuals, which is nice. That guarantee card here from Boots, it's got a date of 22nd 71. So I'm not sure what that is, but I don't think that would have been for the record player. I don't think Boots actually sold this record player. I think it might have been actually for the EMI record cleaner, but even then it seems a bit unlikely. I wouldn't have thought you'd get something like that with a piece of record cleaner cloth, so it might be totally irrelevant, I don't know. So yes, I think it's a Garrett SP25. I'm not sure, just can see if it says the model. Oh, it looks like it doesn't say. It's a model 3000 anyway, so it's not an SP25. And there's the sort of layout of how it works, and just hold this still so you can read it. So that's it, useful itself, interesting information. You don't often get that with a record player. So inside we've got obviously the garage turntable, and it's all in really nice condition. It's got all its original sort of labels included. It looks like it's obviously been well looked after. It's actually pretty clean as well. It's got a bit of fusty smell to it. And here's the turntable. It does 16, 33, 45 and 78. 16 were talking book records. Never seen any over here. They're quite popular in the States. This is the auto changer mechanism, where you stack your records up on this spindle, and when the record finishes it comes back. The arm touches the side of the record that's stacked on the top, works out its size, and then the little wedge here drops the next record down, and it plays the next record. Actually, I think the measurement is probably also done by this arm here. There are various different types of doing it, but I think that may be the measuring arm around the back there. So this will be an idler wheel turntable. The good thing it's been in the left in the off position. That means there should be a flat spot on the rubber pulley. You come to find if it's been left in the manual position, the big rubber pulley rests against the motor spindle and puts a flat spot in on the pulley, and you have to replace the pulley, and it obviously isn't going to be easy. Now we've got ceramic cartridge fitted as standard on these. I'm not entirely sure which model it is. That will be, should be stereo micro groove on one side, and it should be 78 on the other. There you go, you just flip the needle over, and you can see it's that's easy enough to sort of understand how that works. You can use it as a manual or auto change. So basically manual, you press it to manual, select your speed, lift your stylus over and drop it down. There's no queuing lever or anything like that on a modern turntable. Or you can go automatic, so you just put your record on and press auto, and it will just drop the record down, measure it, and play it. So but basically most of the time you use them on manual. Got clips on the side here for holding this auto changer pin, or you can replace it with the normal one, which is probably what I put on in the end. Is just the normal pivots of the spindle, so you don't use the auto changer section of it, and that's probably what I'm going to use for. These are a bit corroded up, but we can polish those up, that's not a problem. We could probably replace them with some sort of like stainless steel ones. So the amplifier's mounted inside here, behind this grill. The grill's in really nice condition, apart from one ding here that I think I could pull out fairly easily with a screwdriver. I'm going to try that in a moment. She was very worried that I was just going to power it up and it was going to make horrible noises. She said when she turned it on, it crackled and made lots of crackling noises, and she sort of panicked, I think, and turned it off. And in the advert it said to go with someone who knows something about electricity. So I don't know if that's me included or not. Some of you probably say no, but so the idea with this amplifier is to, or this record player, is this evening probably get the turntable out, have a look inside, check the state of the turntable. Probably need to lubricate all the pivots and things, because this grease goes really sticky with age. Have a look at the amplifier. Have a look at what caps it uses. It shouldn't be using any wax capacitors. We just need to check a few other bits and pieces just to make sure everything looks all right. Make sure the valves are inserted okay. Most of these sort of record players, the valves will be fine, because you know a record player isn't on for a long period. Not like a radio where it's switched on and people walk away and just leave it. These record players probably weren't on for a long period of time. You see the leatherette cloth, or I think it's just a leatherette Rexine, is in really nice condition. No marks or dings in it at all. I'm actually very pleased with it, because actually after I said I'd have it, I thought, what the hell am I going to do with it, you know? But I did want a record player I could play some of the earlier records on, particularly 78s, that would actually make it sound reasonable, and this certainly should do that. So this is the next clip. I'm going to have a look at stripping the thing down and have a look to see what's needed to get it working properly. Okay, let's power this up, see what it does. We're going to power up in a dim bulb. Obviously we're not sure what the problem is with it. So a dim bulb, for those of you who don't know, is basically a light bulb which is in series with the main supply to the radio, or the I want to test the record player in this case. So what we're doing, we put a 40 watt light bulb in series with the main supply, and what that will do is, if there's a short circuit or there's a fault, you can not only visually see that there's a problem, but you can also prevent damage to the transformer or any of the input of the device under test. So it's like a saggy supply, basically. Well, that's how I could describe it. If the thing starts to demand more power, the voltage will drop off and it will put less current through the device, and it's less likely to cause any damage. Pretty straightforward principle. The other way of doing it was with the Variac. I quite like this idea, is because you can basically switch it on and walk away from it, and you're pretty safe, really. So we've got 40 watts in series. So what we're expecting to see is, when we switch it on, is this light bulb will come on fairly brightly, and slowly it should start to fade. And as it starts to fade, that shows the sign that the filaments are warming up in the amplifier, and the current consumption is starting to reduce. Then after about probably 30 seconds or so, the light bulb should start to get very slightly brighter. If it becomes very bright, or sort of like the full 40 watts, there's a problem. We're drawing too much current. That's fine, because we're putting less risk of damaging anything inside the record player, but it will give us a good indication. So the light bulb is just here. So I'm going to switch the radio on. I expect it to come on fairly brightly and start to dim down, and then, as I say, come up brighter again. So let's switch it on. Okay, you see it's dimming down. And basically the set's warming up now. It's going to take longer because there's less power going into the amplifier, less power into the transformer, so that all the voltages will be lower. We expect that to sort of like slowly increase, but it shouldn't get too bright. If it gets too bright, there could be a fault with the amplifier or valve. Volume turn full up. It's getting brighter, actually, quite bright actually. Okay, can you hear that? Okay, so I've got sound. It's not very loud, but I have definitely got sound. And what I might do, I'm going to leave that for a while. Basically what we're doing now is what we call reforming capacitors. Now, If the capacitors are going to recover, what we're doing is we're charging the capacitors up and they're re-establishing themselves basically, because they've been sitting around for a long period of time. They're probably leaky and drawing excessive current. We need to let them warm up a bit just to see what happens, and then what I'll do, I can actually bypass the supply and then give it full mains, but I don't want to do that yet. We're running a very low supply, so the record player is not doing anything. But probably won't be enough to turn the turntable around, but I'm not sure. The turntable's not turning anyway, but that's probably another problem. But the light's starting to get brighter again. And I'm starting to wonder if there's a problem with this amplifier, because it's getting quite bright again. So I think at this point I'm going to stop it. I'm going to take the top off and get the amplifier out and have a look at that, because I think that's getting too bright. Right, let's have a look at the circuit then, see what we're up against. Pretty straightforward circuit here, slightly drawn, slightly weird by the Hacker engineers. They seem to have decided they were going to start from the right and move to the left. Certainly part of the circuit is like that anyway. Incoming supply is over this side. High voltage rectifier here. This is a high voltage tap, 260 volts. Filament voltages and light lamps, 6.3 volts, and a sort of 6.3 volt filtered section for some of the other stage. This stage here, the B, feeds the preamplifier, so it's actually quite heavily filtered. It's still AC, but it goes through these series resistors, so it should be fairly well filtered. A will provide more current, and that drives the main filaments for the other valves, the other parts of the valve, like the rectifier basically. So that's basically driving the rectifier, and this section is driving the amplifier valves. Gives a bit of decoupling as well to keep noise down and things like that. So we're coming in from the left hand side. Here comes our audio signal in through here. It's a stereo turntable, monoed out by just shorting the two left and rights together. We come in through this resistor here and capacitor into our volume control. We've got a treble control here, which basically, as you turn it down, it lets this capacitor come into circuit, and basically that capacitor is to ground, so it acts as a a low pass filter basically. And then the audio's taken out from the wiper and fed into the first section of valve 1, which is the grid, and from there the audio is passed through the anode and pin 9 of the valve, and it's fed down to the grid of the first valve second section, which is the section B, but it's also fed into the phase splitter. If we come down here and come down here, you'll see it's fed into the grid of the second valve's first section. So what that's doing is it's actually inverting the phase between the grid on pin 8 here, the second part of the valve on valve 1 and the second part of the valve on valve 2. These two phases are out of phase, and that's needed to actually make the push-pull amplifier work. So the out of phase signals arrive here at the speaker of the primary of the transformer, and that will give us our push-pull principle. And basically the output is, after the secondary, is fed straight into the loudspeaker. There's a bit of filtering and things like that just to make sure the amplifier is stable, and then there's a negative feedback that comes down here, back along. This is the base control and feeds back into the amplifier. So basically it's always got a bit of negative feedback, but there's also adjustment for bass control as well. So that's basically also our bass response of the amplifier. And you can see that's fed back into the cathode of the first valve, and it's just that's negative feedback. All the audio amplifiers have negative feedback. It keeps them stable. It does reduce the gain significantly, but it also cuts distortion down as well. So yeah, it's pretty straightforward. Nothing particularly complicated about it. Things we need to check are these capacitors here, C8, 16, 11 and 12, particularly 11 and 12 because they've got the most stress on them. After 12 there's quite a large value resistor that drops this voltage back. I'm not sure what voltage we've got here, but it's biasing. It's probably about 80-90 volts, something like that. But these caps need to be checked as well. And likewise, cathode bypass capacitors C5, C10, there's a couple of others, there's C9, C3. They've got very little voltage across them, but they need to be okay. The amplifier will work fine with them faulty actually, but what it will do is it'll affect the tone response of the amplifier and actually make a serious lacking in bass. Not that it really matters on this model because it's quite bass heavy anyway. There is one other thing I'm sort of vaguely looking into. I know that these record players tend to have a lack of top end a bit. You know, a bit high frequencies don't get through very well. That's mainly down to the cartridges. You know, it's a ceramic cartridge. It's not a moving magnet or moving coil. The response of them is not great. There may be other ways of trying to get a little more tone treble response out of it, but the only way I can really see is to drop the value of C2 right back. But then again, with the tone control wound fully up, this capacitor is basically more or less out of circuit anyway. So yeah, I mean, hopefully it should be a pretty straightforward run through. It should be all ready to go. I wouldn't be surprised if any of these capacitors actually need changing, because these sort of record players are only on for short periods, as I said before. So hopefully everything will be okay. We'll move on to the next step of getting it out and having a look. Okay, here we've got the insides. Not a lot to it, as I said in the previous with the schematic and things. So your output transformer for driving your speaker. The main transformer will be further around the back here somewhere, or probably inside. Oh, there's the main transformer right in front of my eyes. Smoothing capacitor, which is the thing I'm suspicious of at the moment, which we're going to test with the high voltage power supply in a moment. And you've probably got the two push-pull output state transistors valves here, and the driver. And it looks like some more capacitors there. So the first thing I want to do is I want to check any electrolytics. There's another electrolytic here, could be leaky. These four electrolytics here, which are probably the cathode bypasses, need to be checked. But first port of call is we're going to put some voltage across this capacitor. We're going to see if it draws any excessive current. If it does, it's probably that cap's short, and that cap in turn will damage the rectifier if it's leaky. So we need to ascertain that that's okay before we do any more powering up. Right, this is a double stage capacitor, so there's two capacitors in this can with a one common connection. The first stage is to supply the power amplifier, the second stage is the preamplifier, and it's got a series resistor which is actually strapped across the capacitor, which acts as like a filter. I'm using this high voltage power supply, and what I'm going to do is I'm going to apply a high voltage, or the rating voltage that this capacitor is designed to work at, and look for how much current it's drawing. Now I expect to see a few milliamps or so, but I don't expect to see any more than about 5 milliamps. The amplifier's not on, the valves shouldn't be conducting. So basically all I'm doing is testing really the capacitor to make sure it's not leaky. So we're on our volts range here. This is our volts readout, so this is at 1 volt at the moment. We're across the first stage of the capacitor. I'm going to wind this up slowly. This 50 volts. That's our current. Okay, I'm going to wind it up to 190 volts. Okay, so you see it's a bit of sort of jumping around with the meter there. I'm not sure how good the ammeter is on this, but it gives you a ballpark figure of what's going on. We've got current limited to 400 milliamps, which is far more than the valve, the rectifier valve would ever be able to produce in this thing anyway, so you have to be a little bit careful. But we're just watching for any sort of problems of breakdown or anything. It's jumping around a little bit. I think it's probably okay, so I'm going to increase it to 250 volts. And it's going to see probably a bit more than that at normal operation. You see we're up to 6 milliamps now. Just let that settle. Got any signs of anything going wrong, it will jump up to sort of 10 milliamps and I'll shut it off. And initially it looks like it's possibly okay. It's dropping negative every now and then, which suggests that the capacitor is possibly discharging or breaking down, but there's certainly not a short on it. I'm not too worried at the moment. It seems to be okay, so let's turn this voltage down and you should see a negative number appear. Yeah, that shows the capacitor has taken a charge. We're just discharging it now. And that should drop to 0. If that's dropped to 0, there we go. Now I'm going to move it onto the other section of the capacitor. And this is the other side of the resistor, so you can see the capacitor down here. This is the series resistor in strings. So the first one is where these 2 orange wires go in, and then the second side is the filtered side via the resistor. And you can see that in the circuit diagram if we rewind back. So let's increase the voltage again. We're actually measuring current at the moment. Oh, let's turn it off, wrong button. Let's take it up to 250 volts. Basically that other capacitor, the other side of the capacitor, has probably had 250 volts via that series resistor, so that's not a problem. But it doesn't look like there's any problem, to be honest with you, that smoothing capacitor. It looks like it's fine. So the next step to be is to put it back on the dim bulb, I think, with the voltmeter across those capacitors, and just see what voltage we get. We'll do it with maybe a 60 watt bulb this time, maybe a 100 watt bulb. I think that'll be easier. So that looks okay. Yeah, that capacitor looks like it's charged up okay as well. So let's get it wired up to get it back up to a dim bulb with via 100 watts, and then we'll monitor the B plus, as the Americans call it, or the high tension supply. We're expecting, I think we should see about 250 volts when it's up and running. So let's get that sorted out. Okay, what we've done then, we've connected up an analog and voltmeter so it's easy for you to see what's going on. We're looking for 260 volts across the first stage of the capacitor according to the service manual. That's with the dim bulb disengaged. I've got the dim bulb engaged at the moment, and we're still on 40 watts. I didn't change it to 60 watts. This Simpson meter is set to 250 volts full scale deflection. So when the bulb is disabled, when I put the switch over on the bulb, the meter should go beyond the full scale of the meter, and that will give you a good clue that the voltage is correct. So we're on dim bulb at the moment. I'm going to switch it on. You'll see a voltage rise slowly as the valve starts to conduct, and we should probably get to probably less than halfway, but I'm not sure. It depends on how much current is actually passing through the valve. Here we go. So the valve's starting to conduct. HT's coming up. So we're already actually pretty close to 200 volts, 160 volts or something like that. So that's showing a good sign. So we just leave that for a minute just to settle. Now we can at this point just test the inputs by touching the input of the amplifier, see if we've got any sound. Make sure our volume is flat out. I can hear something very quietly. So we have got sound, but it's very, very dim. But obviously, we're nowhere near full power. So what I'm going to do now, I'm going to go bypass the protection, and then we should see this meter climb to off the end of the scale. There we go, which it does, 250 volts. And the audio is still very weak. So we've still got a problem somewhere. So what we need to do is shut it off, which is what I'm going to do. And then check the other side of the smoothing capacitor, see what we've got there. We could have a problem with the one of the output valves. We basically proved at this point that the high voltage supply is there, and that is good. It could be an output valve's failed. It could be another of the preamplifier valves even fallen out. It could have just fallen out the back of its socket. But we're going to go across to the other side of the capacitor now. And this should be a slightly lower voltage of about 250. I'm going to switch it on again without the dim bulb, so we expect full scale. So it should actually go to the end of the scale and not beyond it. It's gone beyond it again, but okay, that's fine. That's making good 250 volts. So the power supply is good. So we need to start now looking at why the amplifier isn't amplifying. Right, so get this amplifier out. Fairly straightforward by the looks of it. Just remove that nut there. Extra light on so you can see. There, and then we've got two little clamps down the side here that looks like they hold with like a little swing plate that swings out just to hold it in position. And there's another one on the other side, and that should allow us to turn around.
turn those brackets round, release the chassis. He says, I'm going to have to take the thing right off. Okay, that's that one turned. So when this corner's a bit tight. Bear in mind, if you are working on here, I don't tend to do a lot of sort of health and safety warnings, but working on this stuff, you do work on it at your own risk. If you're working with valve stuff, there is high voltage present. Obviously with battery radios, you're safe. You know, anything up to sort of like 20-30 volts, you're perfectly safe. Some people get electric shocks off 9-volt batteries, but you're pretty safe, you know, working on voltages up to about 40-50 volts. This stuff has got high voltage DC supply on it. If it's switched on and you touch it, the least you'll get is a nasty electric shock. You could get worse, you could get a very serious electric shock. And it's not so much the electric shock that can actually sort of cause the damage. You can get an electric shock, get thrown back and sort of like smash your head on the wall sort of thing. So it's not just about the electric shock, it's the actual surprise you get when you get the electric shock. And we've had this at work where people have got an electric shock and sort of got thrown clear and sort of injured themselves more on what they did after that rather than the electric shock itself. It's, you know, you have to be a little bit careful. Well, there's the amplifier's free. Just trying to get the connectors out now. So I'm going to stop videoing now. You can see the amplifier's free. Let's get these connectors disconnected and we'll have a look at the valves. Right, I actually was looking for the sort of the rest of the pre-amplifier valves and I realised that there weren't any. It's all done by the push-pull stage. So there's only 2 valves in the amplifier. There's obviously the rectifier, but all the other valves are sort of like multiple segments. So the pre-amplifier and the phase shifting is all done internally in the push-pull output valves, which are V2 and V1. So, alright, we've got low output, so the first thing I want to do is check the valves on the valve tester. So we're going to do that now. So these are ECL86s, and I haven't wiped the dust off them yet, but I'm going to give them a clean up afterwards. So we're going to set the valve tester up to be to calibrate it, and then just going to go through our manual and do the alignment on it and make sure I got all the correct settings. So obviously this is a European British valve, so right at the back of the page. So what ECL86? Where are we? ELEF should be in here. So there's the ECL86. I should have penciled this in, so I hope that's correct. 6C5, 6C5, 6 and 4. Oh, 6C. Let's check that again. 6C5, 6C5. A socket 4. Okay, so we're going to turn it off, put it in socket 4. Okay, go to grid leakage and wait for it to warm up. Now hopefully the meter shouldn't read anything if it's good. The grid leakage is on the bottom scale. Wait for it to warm up. Shorts test. No shorts indicated. Emission. It's coming up. Okay, so it's okay. It's not brilliant. Didn't it warm up properly? So it looks like this valve is pretty good. This tube is actually slightly pessimistic. This valve tester, tube tester is slightly pessimistic. So I'm pretty happy with that. It's come up to 80%. Just check a calibration. It's slightly low. There's a bit of power's drawn on the no grid leakage, no shorts, emissions. Yeah, it's coming up. It's coming up about 80-85%. So let's just give it a little bit of time to warm up. But that valve will certainly produce decent audio. There's nothing wrong with that. So that's the first valve. So just give it a couple of minutes. 30 seconds more or so just to see if it comes up any higher. I'm not going to bother checking the rectifier valve. We've proven that the HT comes up fine. There's no problem with any of the supplies, so that's good, isn't it? Currently testing 90%. I'm happy with that. That proves that that valve is good. So let's move on to the next valve, and hopefully that's the same. Right, this is the second side of the push-pull amplifier. So we're going to switch it on and check for grid emissions. Let's wait for it to warm up. And the other one was showing about 90% once it's warmed up after a couple of minutes. Just checking now. There's grid emissions on the bottom. Short test, no light on. Check for calibration, full scale deflection, and emissions. And here it comes out, it's coming up as well. Taking a little bit of time to come up, which suggests that the valves have, the thing has been used, and they're probably not in new condition, but certainly emitting quite well. Replacement valves for these are sort of not easy to get hold of, not in any good condition anyway. I might have a couple of ECL86s I could go through and have a check actually. But I'm perfectly happy that these are going to perform perfectly well. I don't think the problem is lack of audio is due to the valves being low emission. There, it's come up to 90%, so they're, if nothing else, they're pretty matched. So that's good. I think we're happy with that. I need to put the valves back in and then do a bit of probing around maybe with the scope to find out where the audio is going. Okay, I said we weren't going to check the valve because we knew it was okay. This is the rectifier valve. We've proved that the HT comes up. The valve tester out, let's check it anyway. So we're going to go straight to emissions. We'll go to short test first because obviously it hasn't got any grid leakage because it's just a diode. So let's just power that up, let it warm up just to see if there's anything nasty happening. But the shorts indicator isn't coming on, so that's good. We'll go for emissions and wait for the valve to warm up. He says, just checking our settings again, it's an EZ80. Have I done something wrong here? It definitely works because we had output from it. So why have we got no... EZ80, oh, I've got an EY80. 6A5, 6A5, A, oh, there we go. Wrong control, okay, so there we go. 90%, similar as we got from the output valves. Shorts test, no, nothing wrong with that. Emission is, yeah, about 85%. So, yeah, that's good as well, and no problem there. So the valves test okay, so it's going to be something else. Alright, so we ascertained that the valves are good, the capacitors and the power supply are good, the electrolytics here look, I've quick tested those and they look fine. We're losing audio in the preamp, or not the preamp section, even the feed into the main amplifier. We're not getting audio into this input here, and you can hear the buzz now. We just have to get near it and it will buzz. This is the input. It's pretty weak, but if I go straight to the crock clip, I've got a really strong sound. So it looks to me like there's something wrong with either the volume control pot. It seems to be bloody working now. I wonder if there's a bad connection somewhere. But initially, when I connected it up and feed its audio into here, I had nothing. Now I'm getting good sound. So I'm wondering if it's a really dirty volume control. Though I've never come across one that doesn't produce any output at all. But it could be a bad joint on the back of the amplifier. So I'm going to check and resolder the joints here. But now we seem to be getting audio feeding in. That sounds good. So let's reattach some audio. I'll feed in from my stereo system in the workshop rather than the turntable. See if we get any audio. And try and work out why it's so unreliable. Well, it seems to be working now for some reason. I'm going to resolder these joints on the back of the preamplifier. I'm feeding in the signal from my bench meter. You can hear a lot of hum because obviously everything's sort of in the air. It's a high impedance line. It's a 1001. I think it's a 1 mega ohm input impedance. But we'll just play some bit of music through here just to prove the point it works.
When every night the set and smart is intruding and you departed in studio.
So amplifier seems to be working absolutely fine. So there's a bad connection here somewhere. So I'm just going to go through all the connections, but the amplifier sounds strong. Just like I'd expect it to with the valves testing how they do. So the next thing to do is go through the pots, clean the switches, check solder connections because there's a bad joint here somewhere, and put the turntable in and have a look at see if the turntable works. Well, I've got the turntable back in, but the turntable clearly doesn't work. The amplifier is still working. We can prove that by just touching the stylus. You can hear that's working fine, but the turntable's not starting. Now I can feel resistance against it, and there's a click. So something's switching, but I don't think the motor's seized or the idler pulley's jammed. So let's get the platter off and have a look. I'll try and do that with you in position, but you've just got to pop this circlip out carefully without damaging anything, he says. Pry this cup off maybe. Get that off. The trouble is what happens with these turntables is the grease goes really sort of sticky and hard with time, breaks down. And the only way you can really repair them is to strip all the grease down and replace it with modern synthetic grease. There we go. So that's the platter off. So let's just start it up, see the motor's running. Okay, the motor feels like it's seized. That motor is C-solid. Okay, so that needs a bit of lubrication in it. Okay, so let's have a work on that motor. You can see, you zoom in a bit so you can see. So that's the motor that's the motor shaft there. Runs onto an idler pulley, which is this, and drives onto the platter. And as I was mentioning in the previous part, you know, it's good that you always leave these controls here in the off position. If you leave it in the on position, you'll see that it pulls it over to the motor shaft, and if you leave that over a period of time, that motor digs into the idler wheel, and actually causes the idler wheel to have a big deformation in it. So when you're playing it, you've got a bad wow and flutter because this idler wheel is no longer central. So let's get this motor freed up, or maybe I should rephrase that. Let's get the motor running and head out on the highway. Okay, this is the bottom of the motor. Here's the bottom bearing. So I'm going to try, without taking the motor out, take the bottom of the motor apart and hopefully slide the whole thing apart and be able to get to the motors to lubricate the bearings. So I need to get some oil on it. I tend to use on things like this is just a sort of like a semi-synthetic or fully synthetic engine oil. I've got some in the house actually. Believe it or not, I haven't actually got any in here. If I have, I can't find it. So this is the bottom. The bottom bracket. Take this out. Yeah, so you can feel this bearing seized. Yeah, that bearing was C-solid. I'm not sure that's going to come out. There we go. So that's our armature, and this is the bearing that is all seized up. And you can see, as you can see here, let me see if you can focus on here. See how dirty that is? The grease is all dried up. So I'm going to lubricate that up, pop it back together, and we'll give it another run. Alright, so what I'm going to do is drop a little bit of gear oil in here, extreme pressure oil, just a drop. There we go. That should be good. So that will allow this bottom bearing to actually free up, hopefully, and hopefully that should spin nice and freely. As we've got it inserted, there we go. You can see that's nice and free now. So just put a bit of oil on the top. Let's reassemble the motor, see if we get any turntableage. Okay, whilst we've got the top off, we're just going to go through and lubricate everything else that's got a spindle on it or has a bearing on it. So I'm going to take this idler wheel off, pop this off. There's also a little plastic, what's the word? Increases the diameter of that motor shaft to actually give you the, I think the 78 RPM. That's just dropped off underneath, I think, because it was fallen behind the idler wheel. So I can't find that. So I thought it was underneath the idler wheel. So yeah, basically just I'm going to re-lubricate this idler wheel. Just one drop of oil on it, just a tiny drop. We don't want a lot. That's it. That's probably more than enough. Pop that back on. Also, you don't want to get any rubber oil on the rubber pulley itself because that will slip. If you do, just wash it off with isopropanol. Pop that back on. There we go. That with its little nylon washer. There's a bit too much oil in here, so as you see, it's very awkward to control an oil can or something like this size. You want a tiny drop. Let's see what I'm doing. Okay. Need a pair of pliers to get this clip back on, I think. Bit fiddly. Come on. Come on, you little bugger. It goes on to, that goes on there. So we've got oil on everything now, so it's all sticky. Okay. Then position. Snap it on. Okay. That's on. That's on properly. It's free. That's on properly. Okay, so all I've got to do now is just remove that excess oil I've got on the rubber. Do some isopropanol, and then we're ready to power it up once I've got that little part back on the end of the motor. That just gets all that excess oil off. Run over the whole diameter as well. Get out any sort of like gunge that's on there. You see it comes off quite easily. So all the dirt's coming off the idler wheel. So that idler wheel should be okay now. So just got to lift the platter up, get the little plastic bit that goes on the top of the motor, and then we'll power it up and give it a go.